In software engineering, we are discussing the software testing strategies. In software development, software testing is very important. That is, whenever we make a software, the software has to be correct. It has to be right. So any testing strategy, there can be multiple testing strategy. Every testing strategy has to incorporate the test planning, then the test case design, test execution, the resultant data collection, and then evaluation. So two things have to be together, flexibility also and rigidity also. But these two are, antonyms. Flexibility means these testing strategies should promote a customized testing approach. And rigidity means there has to be a reasonable planning and management tracking as the project progresses. That is, a blend of flexibility and rigidity in any kind of testing has to be promoted, has to be there. So this is the different way, and most of the time we have the unit testing followed by the integration testing, followed by the validation testing, and finally the system testing. And these all are based on certain software development life cycle phases. A strategic approach to software engineering. So there are different testing strategies, but all of them, or mostly all of them, they provide a template. They provide a way for testing, and they all have certain general characteristics, attributes. The first thing is, we need to conduct effective technical reviews. We are just not going to code, doing the static and dynamic analysis. Before that, we are interested in technical reviews. These people will sit, the expert will sit and will see your work. And from the requirement, design, the construction, everywhere the technical reviews should be there. And because of these technical reviews, most of the error which you are going to find in actual testing, they are eliminated, they are fixed. Testing always start with the basic level to the advanced level. That is, it will start with the component level. I am talking about a component. It can even be a function, small function. It can be a component, it can be a class. So then this testing goes outward towards the integration of the entire system. So different testing techniques are there, but they are appropriate, they are suitable for different software engineering approaches and at different points of time. So there is no hard and fast rule of any testing. People say we do white box testing, black box testing. So testing is conducted by the basic level, the initial level. It is always tested by a developer who has developed the software, the team, development team. And then if you're talking about the large products, there is an ITG, independent test group. They also get involved. So all of them, they together, they make the testing work. Testing and debugging. These are different activities, but related activities. That is, testing is to find the error. Debugging is to fix the error. So debugging must be accommodated in any testing strategy. So testing cannot just be done by you need to debug also. A strategy of software testing, as I said, it will start with the low level, component level, even the small source code segment, that it has been correctly implemented, it has been correctly coded, and also the high level test, where we have majority of different systems, they are coming together. So validation will be done against the customer requirement. We'll talk about the verification and validation just now, but just not finding the semicolon. But whatever has been done, are they showing these customer requirements? Are they being made with reference to the customer requirement? Are they traceable to it? Verification and validation. Now in software testing, these two are very important ones. First of all, the software testing is one of the element of verification and validation. And verification and validation is one of the element of the software quality assurance. Software testing, software quality assurance. So, verification is whether software correctly implements a specific function. That is, if you have made something, is it working correctly? This is verification. Validation is what you have done, does the user want? That is, whether a software is traceable to the customer requirement. I'll give an example. Let us say we have written a function as a developer, add a plus b equals c. And if it is producing the result correctly, c is giving the result of a plus b, that is, verification has been done. But user actually wanted subtract and you have given him add. So validation fails because user wants something else. You have given him something else. Though add and subtract function, even if you are giving them, they are working correctly. If you check it, it is verification. But maybe they don't want any of this. They would want multiplication. So Boehm, he states, the verification is, are we building the product right? That is, have we done enough work that the functions are working properly? Validation means, are we building the right product? That is, whatever user want, are we making for him? So this is a kind of Venn diagram. How does this verification validation relate? As I said, they are coming under software testing, which is coming under the software quality assurance. So the customer acceptance test and the usability test, all is the requirement of user. So am I building the right product? This comes under validation. In validation, am I building the product right? For that, we have to check the unit testing, then the integration testing, the various testings are there. And if you combine them, there is an in-between which belongs to both of them, regression testing, system testing, beta testing. In fact, beta testing and alpha testing, they are done with the users only. In the software development lifecycle, we do the requirement, then we design. That is, we first design system design, then we do the architecture, that is the overall structure of the software, then the module design, and finally we code. So the unit testing, it validates the module component level. It will validate it. The integration testing will validate the architecture design. The system design will be validated by the system testing. And finally, the requirements will be validated by the acceptance testing. Verification and validation. The verification verify the intermediate products like the SRS, like the design documents, like the ER diagrams, test plan, traceability matrix. And these are done with the developer point of view, because as a developer, we are verifying what we have done is done correctly or not, or some independent team. They will see what the developer has done is correctly or not. We will verify without executing the software code sometimes. So we'll do the techniques, informal review, inspection, walkthrough, technical and peer review. In validation, this is the final end product, like the developed software or service or system. We need to validate it because it is from the customer point of view, whether his requirement has been fulfilled or not. So this is validated by executing the software code. So functional testing, system testing, smoke testing, regression testing, and many more. So this verification validation, they include Basically, they are the part of software quality assurance. So there are so many activities which will be used for verification and validation. So it can be technical reviews, quality and configuration audits. It can be performance monitoring, simulation, feasibility study, documentation review, database review, algorithm analysis, development testing, usability testing, qualification testing, acceptance testing, and installation testing. So these are the software quality assurance activities done for verification validation. So the testing, you can say that it is the last defender. You can assess your quality. That is, testing can show you whether the quality is there or not. Because errors can be uncovered and can be fixed to make the quality better. But testing is not a safety net. That if you have done testing, the quality is good. You can't test in quality. What does it mean? If before this quality was not there, after also testing there will not be the quality. So Miller relates software testing to quality assurance. He gave a very good, you can say, bridge. He said the underlying motion or motivation of program testing is to affirm software quality with certain methods that can be economically and effectively applied to both large scale and small scale system. Those methods which we use in any of the project so that we can ascertain the quality. Organizing the software testing. So most of the time the developers are asked to test the software. Now the user is not there right now, but developer has made the software. But developer, they may have their vested interest because they would like to show that they have done a good work, the program is error free, they have done exactly according to the customer requirement, they have completed the work on schedule, they are doing it under a budget. Everyone has to have an appraisal sometime. So developers, you can say most of the developers think that the software is their baby. So they would like to protect it. And they would like to show that what we have done is good. But testing is inherently destructive. Someone would, or testing would, try to destroy the software so that whatever points are there can be uncovered. So if error are present, even if you keep your eyes closed, customer will definitely find them. So whenever you are doing this testing, there are certain misconceptions. What are these? Developer should do no testing at all. This is a misconception. In fact, the unit testing is done only by developer only. Developer should do no testing at all. That is not there. Even if you are working in, say, Visual Studio and integrated development environment is there, you will use a debugger. You will use the, some breakpoints. You are doing testing as a developer. Second thing is software should be tossed over the wall to strangers to test mercilessly. That is, just throw it and let another people destroy it so that the errors can be found out. This is also not true. Testing is done to improve the quality, to find out the errors so that the customer doesn't get agitated or get upset. Testers get involved only when the testing steps are about to begin. This is also a misconception. Right from the requirement, from design, the coding, every time, everywhere, tester needs to be there. Because the test planning, the tester has to be there. The design, because most of the testing is done against the design, not against the code. Mostly people think that the coding is testing. No, it's not there. The requirement is also tested. Organizing for software testing. The software developer is always responsible for the basic level testing, the individual code testing, the component testing. For example, he has made a function, say add. Okay. He has made certain classes. Now this basic level testing will be done by developer only, the software team or the development team. Now developer also does most of the time the integration testing. That is a testing step that leads to the construction and test of the complete software architecture. Because when we go to the architecture, then the different team may come. So the unit testing and the integration testing, most of the time, because integration testing is the component are combined and then tested. Component testing is unit testing, component combined testing is integration testing. But once these testing are complete, then only an independent test group or some quality team or QA, QC will come. So the developer and the ITG, independent test group, they would work closely throughout the software project because they want to ensure that the thorough testing has been done or thorough test will be conducted. So why do we want the independent test group? Because we want the freedom. There has to be someone which is not from the team, the development team. Then only the things can be uncovered. The problem can be uncovered. But the developer has to be available. Developer must be available to correct the errors which are uncovered. So ITG can be a part of a team. For example, there is a whole project team. So there will be an ITG team, that is quality assurance, quality control, the testing team you can say. And they are involved during the analysis and design also, planning and specifying the test procedures also throughout the large product. If the product is large, the system is going to be made which is large project. From initial to the end level, they will be involved. Because testing is all about checking every time. So checks has to be there. This is the ITG. This is the ITG role. So ITG reports to the software quality assurance organization if they are part of the team or they are an independent team. Achieving a degree of independence. So ITG is not reporting to the program manager or the software manager. They are actually reporting it to the quality team or quality head. The quality head will ensure that things are done correctly. The proper testing has been done so that the errors are uncovered and they are not propagated or they are not given to the user, because the user doesn't want, user want an error-free software. That is the whole quality aspect. Software testing strategy. Just see this spiral diagram. The strategy of the software testing, it can be assumed or viewed as a context to the spiral. Initial level, we develop small code, a component, class or a web app, content. So unit testing will be done. So unit testing is the basic testing, begins at the vertex of the spiral and it will concentrate and focus on each unit of the software as implemented in the source code. So we are checking here for the small component. Now it goes outward, from the vertex outward. So this goes to integration testing. Now the code component has been tested, they are combined and they are tested. So this is integration testing. So this focus is on design and the construction of the software architecture. So here the integration testing is done with respect to the design and the software architecture. Then we go again outward. Then we do the validation testing. And this validation testing, as I said, validation is done with respect to the requirement. So software requirement is the basis here. Then the system testing. Now the software, along with all the major system elements with which the software is going to work, are tested as a whole. So testing in software engineering is series of these 4 steps implemented sequentially. Initially, we'll focus on the component, ensuring that it functions properly as a unit, a component or a class or a web app content. They work as a unit. That is why the name is called as unit testing. I hope you got the idea. because a unit is a small component. So when this component work as a unit, this one component, unit testing. So in unit testing, see, in your program you will write multiple if else, multiple while, do while, and switches, different kind of control structure will be there, if else, etc. So all the path need to be covered. Maximum error detection will only be done when you have the complete coverage of all the control structure. And next, the components are being checked. They are assembled, they are integrated to form a complete software package. They are like bricks. Components are like bricks, and they will make a wall. So these are combined. So integration testing addresses what? The problems of verification and the program construction. Because independently the module may work properly. What about combining them? Whether they work properly or not. So test case design, it focus on input and outputs. Because what you are feeding to your module, to your function, to your component, or to your component combined, what are the inputs and are you getting proper outputs? Validation testing is actually done against the software requirement specification. So this provides final assurance that software meets all function, behavioral, and performance requirements. So once this validation is being done, all the different system elements, it can be hardware, it can be people, it can be databases, or multiple things, a large product can have many. So once validation is done, these are all combined, all these elements, and then finally the last spiral you see here, system testing is done. So systems testing verifies that all elements, all system elements, they mesh, they gel properly, and they give overall system function or performance which is intended. Are they achieved? Most of the time, anyone in the software team or the novice in software field, they will ask, when are we done testing? What is the end point of testing? There can be multiple responses. The first response can be, you are never done testing. From your shoulder, the testing goes to the user shoulder. So the burden simply shifts from you, that is as a developer, to the end user. This can be a simple response. Testing is never ending. It goes round and round because people need change. People need they want to change your software. Another response is, if you have time, money, do it. When you are scarce of it, don't do it. There are certain approach, like the clean room software engineering. Now these kind of approach, they are suggesting statistical use techniques, and that execute a series of tests derived from a statistical sample of all possible program execution by all users from a targeted population. So people say that this is you can decide when the testing will end in this kind of approach. So you are 100% sure all the testing has been done in this clean room. We'll talk about that later. But this is how it is done. Tom Gill, he argues that the software testing strategy is going to succeed only when the testing department or the software tester does certain things. First is specify the product requirement, not in the worldly manner or running sentences. It has to be quantifiable before even the testing commences. The testing objectives, why you are doing it, what are your purpose, objective has to be stated explicitly. And the user, there are different user, experience, less experience, novice, or the user can be only a maintenance user. He will use sometimes your software. So the profile of each user category has to be fixed. And we have to develop a testing plan that emphasizes on rapid cycle testing. As I said, the testing cannot be completed. There is no end point. So a proper testing has to be done. and then build robust software that is designed to test itself. Actually, this is called anti-bugging. We'll talk about that. But a good software is which shows graceful degradation. Even if some problem is there, it will tell you this is the problem, and it can regain its motivation and work the way it was working, rather than killing your system. Technical reviews are very important, because you're just not do the dynamic analysis, static analysis. If someone is their expert, has already seen, there will be benefit. Conduct technical reviews to assess the test strategy and test case themselves. Testing is done to find the error, but there should be technical reviews to test the testing also. Test strategy, test cases have to be tested by they have to be tested again, and to develop a continuous improvement approach. For example, CMM levels, ISO levels. If you are not able to achieve that, but still try for continuous improvement approach, because that will make your software stable, that will make your company profitable. Okay, this is the first part. We'll be taking a few more of these. Thank you so much. Take care of yourself.